In this section, we're going to learn about some important concepts you may have heard about in an economics class already, known as consumer surplus and producer surplus. Before we get to consumer surplus, let's talk about consumers' willingness to spend. Here's an example. Suppose a music department at a grade school wants to purchase an upright bass for its students to use, maybe in a symphony group, right? The school would be willing to purchase a second upright bass if it were offered at a slightly lower price than the first. Like a buy one, get one half off kind of deal. They may even be willing to purchase a third upright bass if the price was right. But eventually the music department is not willing to purchase another upright bass because there would be little or no need for it, no matter how cheaply it was offered. What's the point of accumulating a closet full of upright basses if there's not enough students to play them? It's just wasted space and it's wasted money. And so there's going to come a point where the consumer is not willing to buy any additional product at lower costs. Okay, it's not worth it. So the total consumer willingness to spend for up to Q naught units of a commodity is given by, I'm calling this WS for willingness to spend. So we're right here. WS, willingness to spend. How much are they willing to spend? Now this is found by taking the integral from 0 to that top quantity that you're being given of your demand function. D is your demand function. D of Q is your demand function. Is demand. And so this is equivalent to a price, okay? So if you're demanding, or if your demand is Q units, you can calculate the price to charge to meet that demand, all right? Oh, that's written right below. I have to read what I wrote. And so this is the demand function for your commodity. So here's an example for consumer willingness to spend. This is going to help you out when you start to do the homework for 5.5. Find the total amount of money consumers are willing to spend to obtain 5 units of the commodity if the consumer's demand function is given in terms of dollars per unit. Sketch the demand curve and interpret the consumer willingness to spend as an area, which involves an integral. Okay, so we're going to set up the integral and we're going to calculate it by hand. And then if you would like to check on a calculator, you may. But I do want to see all of your steps that you're going to do this by hand on a test problem. So you're going to start by sketching. And I would definitely use your graphing calculator to figure out what this graph is going to look like. It's going to be a curve that goes down, okay? And it's going to cross the y-axis at wherever Q is equal to 0. So 300 over 1, let's call it 300. So the axes, if you label appropriately, the x-axis represents your quantity, and the y-axis in this case represents your demand, or you could call that price if you wanted to. The value 5 is the upper quantity that we want to consider. And so the area that is beneath the curve from 0 to 5, beneath the demand curve from 0 to 5, is the amount that the consumer is willing to spend. That area is the willingness to spend quantity. So we want to integrate our demand function from 0 to 5, and your demand function was given 300 over 0.1 Q plus 1 squared with respect to Q. So to integrate this by hand, we want to do a U substitution. Let U equal 0.1 Q plus 1. So that means that du is equal to 0.1 dq. And I'm going to go ahead and just put in that constant 0.1 here, and I'm going to compensate by dividing by 0.1. Well, think about 0.1. 0.1 is the same as 1/10. Here off to the side, let me write this down. 0.1 is the same as 1/10. And so if you've just included a factor of 1/10, the opposite of that would be to multiply by 10 over 1. Okay, so that's what I'm going to put in the front of the integral. So this is the integral, 10 times the integral, 300 over u squared with respect to u now, okay? Because with your substitution, the u is the bottom part. The du is going to be this 0.1 dq, okay? So that becomes your du. And so the 300 hasn't gone anywhere, it's still there. So go ahead and finish your integral. I left off my bounds because I've changed my variable from q to u, and I don't want to confuse with the new upper and lower bounds. We're just going to leave those off. So you integrate 300 over u squared, and you will get 300 u to the minus 1 over minus 1. This is negative, well, let's see, negative, cooperate, there we go, 3,000 u to the minus 1. Okay, so now I'm going to go and replace the u with what it's equivalent to, negative 300, and instead of putting it on top, I'm going to write it on the bottom, 0.1q plus 1, now it's to the positive 1. This is going to now be evaluated from 0 to 5. So remember, you take the upper limit, subtract the lower limit, you will get, let's see, I believe I'm off by a 0 right there. Okay, you will end up getting 1,000. Don't forget to substitute the 5 and then the 0 and subtract those two answers, top minus bottom. And so the amount that the consumers are willing to spend is $1,000 to purchase up to 5 units. All right, they're not willing to spend anything more than that. So that's consumer willingness to spend. Now, this is related to the idea of consumers' surplus, because that's what they're willing to spend. But maybe they'll cut a deal and they'll actually end up spending less. And whatever is the leftover that they saved, that's your consumer's surplus. So that's coming up right now. If Q naught units of a commodity are sold at a price P naught per unit, and if P is equal to your demand function, then consumer's surplus, which I'm going to abbreviate with CS, consumer's surplus is equal to the total amount consumers are willing to spend for that many units minus the amount that they actually spent for those Q units, okay? And so the way we do this, let me show you in the graph that you see right above this. If I have shaded in, I'm actually going to see if I can take that out. Good. All right, if I locate this ordered pair, so I would need to calculate the y coordinate, okay? And that's whatever P naught would be. So 5 is your Q naught, and its y coordinate would be your P naught. And so the little rectangle that you see right there, that's the amount that they would have actually spent. They actually spent that much, okay? I'm actually going to shade that in a different color. This rectangle, the area that rectangle contains, tells you how much the consumers spent. Actual money spent, okay? Now the area that is beneath the demand curve, including that green rectangle, is what they would have been willing to fork out, okay? So the red piece I've just put some hash lines in there. This is what they would have been willing to spend. Willing to spend. Okay? And so you can understand that if they only spent the green section, but they were willing to spend the red section, anything that's in red that's not green is what they would have saved. So think of this as if you're buying a used car and you're going to the car dealer and you have like $5,000 you want to spend, right? That's your budget. You can't go any higher. But of course, you're not telling the salesperson this because you want to get a deal, right? And so if you're willing to spend $5,000, but you cut a deal and you only spend $4,500, then the extra $500 is your surplus as a consumer. That's the money that you saved. That's what consumer surplus is all about. Okay, so you take how much you're willing to spend, you subtract out what you actually spent, and that's your surplus. And so the integral is going to find the integral from 0 to Q naught under the demand function minus P naught Q naught. This is the rectangle. That's the area of the rectangle. So up in your picture, that would be that green section. Okay. That's what they actually spent. The integral tells you what they were willing to spend. So that's the red hashed line area, willing to spend. That's the integral part, minus the P naught Q naught, that's the area of the rectangle. Where are we getting that from? Well, a rectangle is base times height, okay, or vice versa. And so if I take the height, which is P naught, times the base, which is Q naught. That gives me the area of that green piece. You subtract them, what's left over is your consumer surplus. Okay, so this is a picture that I couldn't fit on the first page of what I was just talking about, using the exact same type of scenario we just discussed up in our problem with the generic demand function that was provided in the example 1. Okay, so this is another type of an example. Same idea. Your demand function is sketched in pink right there. The first picture, the first graph is showing you the blue area, which is what you're willing to spend. All right, this is you going into the car dealer and you have $5,000 that you could spend on a used car, but you want to try to save some money. Right? You're hoping not to have to spend everything that you have available. Okay, so you end up actually paying whatever graph B looks like. So the area that you see, the rectangle in graph B, is telling you what you actually paid. So you take your graph A, your big picture, minus what you've actually spent in graph B. And then in graph C, that's your surplus. This is the money that you saved. Okay? And so this is an idea of what consumer surplus looks like. Now, think about producer surplus, because the car dealer wants to make money on your deal as well. So you guys want to both come out as if you got a good deal, right? So you want to come out by saving money and spending less on your car, and then the dealer wants to come out by charging you more than they would have, like their minimum bottom line, okay? They made a little extra money on the deal, you saved a little money on the deal, and you're both happy, theoretically. But anyway, that would be producer's surplus from the producer's perspective. So in this case, once again, we have Q units of a commodity that were sold at a price P naught per unit. P is equal to your supply function now. Remember how consumer surplus worked with demand? Well, producer's surplus works with supply, okay? That's your producer's supply function. That's the price they're willing to supply that quantity of units. Okay, so producer's surplus, which I'm going to abbreviate with PS, producer surplus is the total amount that they're willing to accept for that many units, or how about the amount that they're going to be willing to accept for the sale of that car, minus the actual amount that they actually received from that sale of Q units, and what's left over is your producer surplus. And so the integral is backwards, it looks like. So now you've got the rectangle area first, which is the area of, represents how much they actually made on the deal, minus the integral of the supply function. So let me see if I can draw you a graph. So supply functions typically go like this. Okay, they're going to go up. So that's my supply function. This is my quantity axis. This I'm going to label as price. My y-axis we're going to call price. And let's say that this is the number of units that I'm referring to as my Q naught. And the corresponding price that goes with that is right over here. Okay, so the first thing you're going to want to do is once this Q naught is given to you, you're going to plug that into your supply function to figure out the y coordinate to get that P naught, that price value. Okay, now producer surplus is the money that they made off of you, off of the deal. And so think about, there's my green rectangle, okay? That's the money they made, right? This is the amount that they would have been willing to accept. And the leftover part is extra money. So the red is like the bottom line. That's the minimum they need to stay in business, let's say. And the green section tells you, that green rectangle tells you how much total money they actually made. And so the part that's left over is your producer's surplus, which is in that section that's above the supply function but below this dotted line. That's your producer's surplus. A lot of times you're going to be putting both of these together. You're going to put producer and consumer all on the same graph. So let me see if I can draw you a sketch on what that might look like. And that other graph's getting a little muddled, so we'll start over. So there's my supply function. A demand function is going to go downward like this. It could be linear, it could be curved, but it's going to have that same overall rate or path, I guess. It's going to be going downward in some fashion. This point right here has a special name. That's where supply is equal to demand. You might know what that's called. That's called your equilibrium point. And that is where supply meets demand. Okay? That's a particular quantity. So my axis here is quantity, my axis here is price. And so at that equilibrium quantity, that corresponds to an equilibrium price. So let's call that Q naught and we'll call that P naught. Okay, so it's like an ordered pair, Q naught and P naught. And that's what you're going to want to find when you're given both supply and demand. You're given the supply, you're given the demand. You want to find that point of equilibrium just by setting the supply equation equal to your demand function and solve for Q, right? And that'll tell you the value here on the x-axis, and then you can find the y-coordinate by plugging it in to either the demand or the supply function to get that price. Got to get that equilibrium point, because anything that's above the equilibrium point is consumer surplus. I made it worse. This is consumer surplus. And if you went back to the first page or the top of this page rather, where we had the consumer surplus drawn in, you can see it's on top of that horizontal line, okay? But so it's between that price line and the demand function. That's your consumer surplus. The part that's below, put it in this color, this is producer's surplus. Producer's surplus. Okay, and the rectangle that I've been referring to is here. Okay, that's what actually got paid for the commodity. That green rectangle is actually what got paid. And so depending on your perspective, consumer surplus would be the money that was saved from the consumer's perspective. And the producer is hoping to make a little extra money on the deal. And that is shaded. I lost it, but it's here. That's your producer surplus. We will always work with consumer and producer surplus when the market is in equilibrium, and that is when supply is equal to demand. It's your ideal market, and that is why that's your first step. Find the equilibrium point. If you have both supply and demand, you've got to find that equilibrium point first. Get that first.